Hello everyone, welcome to the Mining Match. And today is going to be a special presentation because we don't have a guest speaker. The speaker is myself. But before we start the meeting today, I want to announce about Spanomine. If you are in the mining industry, you work in Latin America, or you want to do business in Latin America, in the mining industry, you should join Spanomine. We provide professional development and connection to the Latin American community. All right, so, well, as I said, today I'm going to be speaking myself. I just starting to do a presentation right now. All right, so let's begin. My name is Alan San Martin, and I am a mining consultant with a great team of consultants based in Toronto called Micon International. I can summarize Micon as 3 words: integrity, competence, independence. That's all you need to be a mining consultant. And you can find us in miconinternational.com, as you can see there in our website. All right, so let's begin. Today I put a brief summary. This is a very high-level recommendations or tips when it comes to do resource estimation. So I just put 10 tips, and let's start right with number 1. Data. Data. You know, everything that we do to estimate a mineral deposit is based on data. So as the foundation of everything you build on that data foundation is critical. So you have to really check from the collection, the quality control. The sampling procedures are very, very important because that's going to give you the value, what is in the ground. And the database itself. The database needs to be really organized and easy to use, and has to be auditable as well. So all of that has to do with data is the foundation of everything. And like the old saying says, garbage in, garbage out. And that's true. It's always the case. So make no mistake, if your data is not good, you're not going anywhere. Okay? You'll be directly to failure. All right, that's number 1. Number 2, once you pass the data proof and you have a beautiful data set, you have everything you need, or at least you think you have everything you need. The most beautiful thing you can do with your data is to slice it with the statistical knife. I'm just using a metaphor. You do thorough statistics. It's very important to take into account the historical data, the data source, the data type, the assay method, and you have to do comparisons. You need to understand how your data is built, because data is not always, well, sometimes it's built in a single campaign, but most of the time data is excuse me, I have to admit people. Okay, data is built over time and in different for different people, different companies, different times and types. So you have to really understand your data with the statistics, and you group it and you compare. So because the data is like doing what is called data mining, right? you find out what the data is telling you, and statistics is the best tool. All right, so number 3. Yes, we have to deal, okay, when we talk about resource estimation, we are dealing with Earth, right? So the foundation of everything, aside of your data, is to know the geology. And I'm talking about knowing really what is going on, geological framework of this deposit. And every deposit is unique. Absolutely. So when you are going to start doing a resource estimation, make sure you understand fully the geology. And if you don't understand it, you talk to the people that are doing the exploration in a day by day. They are knowing a lot of details of the geology of the deposit, like the origin, the genetic model, like how it was formed, the different events, different structures, alteration, and lithologies, etc., etc. So you have to understand your geology. And from the geology, we go into the point of domains. What it means, a domain? A domain is when you know your geology, and then you have your data set in order. You have to find out what are the relationships. And I'm talking about geological domains. The geological domains are very important to establish at the beginning, because with this, you will guide your estimation process. Geological domains means that the geology and the grade, because that's what we're talking about value, the grade, have continuity. And ideally, they need to be constructed based on the next steps you're going to do, like searching or interpolation. So you have to think about those, and the domains need to be constructed carefully, because that's the foundation of the actual estimation. All right, number 5, compositing. Yeah, compositing, I call it the crux of the entire resource estimation process. Why? Because these tiny dots, everything you know about your data, your statistics, your geology, your domains, all of those are going to be represented in a single dot of composites. And in that dot is going to inform how your geostatistics are going to be, your parameters, how your block model is going to be filled with attributes, not only grades, but all other attributes, multiple grades and different attributes. So the composites, they, as you can read there, they need to carry all the essential information and the necessary details, categories, and the most important one here in the last one, capping. I didn't put capping as a single recommendation, because it's a whole chapter to discuss, but they need to be capped. Cap means that you reduce the influence of outliers in your data. Okay, but that's another topic that it can be a whole presentation. So compositing is the crux of the entire mineral resource estimation. Okay, if you build these dots properly, you're going to have you're going to be doing a good job. Okay, number 6, geostatistics. All right, in the last few decades, I think geostatistics has been taking more and more importance in the mineral resource estimation, but we also have to take into account that geostatistics is not cannot be run by itself. It's always dependent on all the good work you have done before, prior to get until you get the composites. And I'm talking about knowing the geology, the domains, and having good composites with all the codes and the capping and everything. So only then you will get the geostatistics properly done. Because I said that and I said in my article that is published in our website in Micron, that geostatistics is not the panacea of resource estimation. But don't get me wrong, I'm not saying that geostatistics doesn't work. I'm saying that geostatistics has to be taken care properly with a very strong geological framework. Because in my experience, I'm talking about just my experience, my opinion, I found that there's this excessive devotion for geostatistics. I put it that way. It's like, if you're doing geostatistics, oh, your resource estimate must be right or must be perfect because you have done very strong advanced geostatistics. And that's not the case. The most important thing is the geology and the data to be correct, and your understanding of the geology and your thinking, because you have to decide. The geostatistics are just a tool to help you decide what estimation parameters you're going to be using. Okay, let's leave it at that, and let's go to number 7. Yeah, the block model. Once you get to that point where you have the composites, everything is perfect, you get your block model, because the block model is imagine is like a 3D picture. You know, pictures are 2D, but imagine a 3D picture. Can you imagine that? And the blocks are like the pixels. And so every block is how you represent volume. You know? So the block model is a 3D matrix that represents a piece of volume of the rock. And with this, you can really understand or do a 3D mapping of your estimate. That's how you represent, and the block model is the ultimate representation of all your estimate. And it carries these boxes, these blocks. They need to have a proper size, typically related to the data spacing, like 3 times or a third of the data spacing is a good size. It's just a rule of thumb, but it's not always the case. Sometimes you need to have very small block size, depending on the geometry of the deposit. If it's narrow veins, sometimes you need to have sub-blocks to account for details of resolution. So think about that. And the block model can carry infinite numbers of attributes, not only grades, but the density, the values, and so many other attributes necessary for the following steps, especially in mine planning. So when you're doing a resource estimation, you, like I said here, you have to think about mining, because that's the purpose of doing a resource estimation. It has an economic purpose. All right, so let's move on to number 8, density. Yeah, I said before that the block models are volumes, but volume times density give you tonnage. So the density of the rock is very important to estimate your tonnages. And density is not always the same everywhere. It varies based on lithology, different rock types. They have different weights. So you have to know all these details to do a proper estimate of the tonnages. And don't forget about the waste material, the material that at the beginning you don't care about, that rock that has no value. You also need to know the density of that rock. So, and it's better to have bulk density because it's a more representative, and make sure you have enough for all your mineral deposit. Number 9. All right, so here, validation. It doesn't matter how much experience you have or if you are very knowledgeable of the mineral deposit, but you can always do an estimation only, you know, and no one has or owns the truth. You know what I mean? Your model could be wrong. And this is a say from this mathematician, George Box, that says, essentially, all models are wrong, but some are useful. Well, it's putting it this way, but it doesn't mean that are wrong. It's just that no one can say, my model is right and your model is wrong. No. They're only estimates. And you have to do validation. And sometimes you find that the input or the composite, which is the input, is not quite represented in the output, which is the block model. And you need to do some corrections sometimes. And so the resource estimation is an art combined with science, okay? And you have to have opinions for different people so you get it right. And only you will get to really know the truth when you are in mining phase. When you are mining, that's the only time when you really know what is in the ground. Before, you're just estimating. So keep in mind that it's an estimate, okay? So, and for example, sometimes you need to vary some parameters just to see what happens. And if you are more comfortable with the results, so you will do that. It's many iterations. Okay, so once you do that, you have a full finished block model, you're happy, and it looks nice and has good numbers. Now you have to let it know to the world. You have to publish. So, but before you do that, publishing of this information, which you call a mineral resource statement, is done differently everywhere. And we had my colleague Tanya Ilievich. She did a very good presentation about mineral resource reporting. You can go and find it in our YouTube channel to see more about this. You see here more details about reporting, but I'm just going to tell you the basics here. And now remember that all this work that you have done, you have the block model. Not every block is a resource. You know, a mineral resource only happens when it has reasonable prospects for economic extraction. What that means? It means that you cannot just report everything in the block model and you call it a resource. No, you have to demonstrate that it is economic to go and mine it eventually, you know, either by a surface mining method or underground method. So you have to put your mining method constraint, and only that portion can be declared as a mineral resource with the appropriate reporting code, of course. Okay. Well, I think I have finished, but I'm just going to do some final comments. Yeah, like I said, the mineral resource estimation is an art and science. You know, you have to work with a team. You cannot make all the decisions yourself. Nobody knows everything. So you have to have experienced geologists, mining engineers, metallurgists, because all of these parameters are key in all the decisions you make into put together a mineral resource estimation. So in Micron, we have plenty of a very strong team to do all resource estimations, and we have been in almost every country in the world, and so we can help you. And the last comment is that there's no room for fatal flaw here. You know, once you publish something and is wrong, like a fatal flaw is like it's completely wrong, right? You are done for your career. So resource estimation is a very high responsibility job, you know, because whatever you're saying, you're publishing into the world, and people are making decisions about their money. You know, investors, they decide, okay, I'm gonna invest here because there is such and such tons and grades in this mineral deposit, and I want to invest. And if this is wrong, well, you'll be in huge troubles. So, okay, so that's why you have to always check and have a great team so you can produce a wonderful resource estimation.